Hello and welcome to the section 1.2 lecture today for our Bridges geometry class. Today we're going to be looking at some lines and line segments more than anything. So let's jump right into it and try to make this go somewhat okay. We've got some things that kind of double back on each other and some things that are a little bit more in depth than we had yesterday. So the first thing we have is a line segment. Now, the definition of a line segment is it is a portion of a line or a segment of a line. Oh, come on, don't do that. I ended up writing what I said other than, yeah. A portion of a line that ends in points. Okay. Now I'm going to use just kind of one visual for a lot of these. So one diagram here. So a line segment is just the portion of a line that ends in points. Now I am going to put 3 points on here to show something a little bit different between today and yesterday. So yesterday we talked about lines and how they go on forever, wrap around and meet right back up where they started. So lines will go forever. Line segments end. They have ending locations. So if we were talking about a line here, there would be no difference between line AC and line AB. Those would be the same thing, because really all you're doing is you're just kind of setting where the other part of the line is, just kind of a direction and, which direction to take off in, and then you're good to go. The difference here is, or I should say, when we're dealing with line segments, there is a difference. Okay, if I'm talking about this entire line segment, it's segment AC, and we use this notation for that we have AC with a line over it. Okay. The difference between this one and yesterday is yesterday there were arrows on the ends of this little line. Today there's not. Okay? And that is a completely different thing than saying AB. AB today as a line segment only talks about from A to B and ending right there. That would be segment AB. Okay, so there is a difference between those two. And then there's also a difference between this AC and then just writing AC without the line over it. There's a difference between those two things as well. And what I really want you to grasp onto, not to really think about that too much, but I kind of do, is that when I have AC with the segment symbol over it, saying this line segment AC, I want you to think of that as an actual tangible object, something that you can touch, move, doesn't matter how it looks in space, you can turn it around, you can spin it around, anything like that. Okay, that is the object, AC. It is the physical line segment. Think of it like a stick. If I write AC without the line over it, that's actually what we consider to be the measure of the line segment. And the way we measure line segments is by length. So that would be the length of the segment AC. So we want to know which one we're talking about, because this one is just a number. This is just a number. It's the number that represents the length of AC. The other one is a physical object. It is the stick that shows what AC looks like. Okay. Now I think in everybody's normal version of the idea of between, we can all agree that on this line segment, B is between A and C. And so we're going to kind of use that as a model here. B is between A and C if the following two things happen. Okay, the first is that if A, B, and C are collinear, kind of separate this out a little bit. Okay. So if A, B, and C are collinear, maybe I overdid that a little bit. There we go. So if A, B, and C are collinear, that's the first part that has to happen. And then the second part that has to happen to know that these are between, or that B is between A and C, is if this equation holds true. AB plus BC is equal to AC. Okay? So we know that they're connected. They're all on the same line, and they're connected by a line. And if this piece plus this piece adds up to the whole thing, that's what it takes for a point to be between two other points. Okay. Now, more talk on the length of segments comes when we start talking about congruent segments. We would say that two segments are congruent pen's lagging a little bit. The symbol for congruent is an equal sign with a little wave on the top. They're congruent if they have the same length. Now, let me move some of this around a little bit. Try to give myself a little bit more room here. And we'll move that right there, and we can go ahead and just get rid of that. Okay, so if they have the same length. Because there's not a whole lot to congruent when it comes to segments. They don't have to be facing the same way. They don't have to be put end to end. They don't have to be stacked on each other. There's no other rule other than they're the same length. They have the same measurement. Then they would be congruent. Okay. The main result that we're going to use today is what we call the segment addition postulate. Okay, a postulate is just it's one of the kind of 5 fancy words for fact in math. So something that we know is true. And this one is called the segment addition postulate. Now, it's kind of weird to write it because it's pretty much saying the same thing as the betweenness of points definition, just in kind of a different order. It has 2 requirements for the setup, which are 2 pieces of this. So let's say it this way. Let's say if, and now I have 2 things that are going to result in one thing. If A, B, and C are collinear, and we'll say B is between A and C. If I have those 2 things, then I can say, again, my pen's lagging, it's kind of bothering me, maybe not anybody else, but then I can say that this statement, the AB plus BC equals AC. Now, I hate to break it to anybody, but we just spent way too much time basically stating that one piece plus another piece equals the whole thing. Now there were the other things in there that if those 3 points are all on the same line, and there's one point that's in between the 2 other points, then from the start to the middle, and the middle to the end, if I add those two things together, it equals the whole thing. So yeah, a lot of work to say that. Let's look at some examples at using this. And I made sure to stress in class, and I'll do no less here, don't make these harder than they have to be. I'm looking for LM. And that's saying that some length plus 6 of whatever equals 11. I believe it has to be 5. Because 5 plus 6 equals 11. Don't make it harder than it has to be. Now, the technical side of things says, well, yeah, L, M, and N are all collinear, so that's met. M is between L and N, so then LM plus MN equals the whole thing. I don't need us to show all that. I don't need us to worry about all that. We can just take it for what it shows. And I'm good with just saying that it's 5 because that's the number you add to 6 to make it 11. On the next one, some number plus 6 equals 13. Okay, it's 7, right? When the problem's easy, make it easy. Some of these other ones get a little bit tougher. Like these ones, there's some variables involved, and we can deal with that. The one thing that I do want to encourage you is make sure you know what you're trying to find, and don't stop too early. Okay. So this one says I'm trying to find CB. That's from there to there. And that's 4x plus 2, but I need to know what x is first. Well, this piece plus this piece has to add up to the entire 15. So I get 3x minus 1 plus 4x plus 2 has to equal 15. Combine like terms, I get 7x plus 1. Pause there if you have to. I've done it a couple times already today, so I can see where this is going. It tells me 7x equals 14, which means x is equal to 2. 2 times 7 gives me 14. But don't stop there, because that's not our goal. Our goal wasn't to find out what x is. We needed to know what x is in order to do the rest of this. And I guess I've been out of frame the whole time. You're welcome. So 4x plus 2 with x equals 2 means I'm going to take 4 times 2 plus 2. 4 times 2 is 8. 8 plus 2 is 10. So we get 10 for our value of CB. That's how long CB is. All right, the next one, I've got x plus 21 and 2 combine to give me 2x plus 35. X plus 21 plus 2 is really x plus 23 equals 2x plus 35. I can go ahead and subtract x from both sides, and I'm going to subtract 35 from both sides. If you need to do that in 2 steps, feel free, but I'm kind of at the assumption that we can handle this level of algebra. That's going to give me negative 12. 2x minus x. I'm not going to overthink that. That's just x. So x is negative 12. Now that's a little concerning because in geometry we can't have negative lengths, but x isn't a length. So we should be okay. As long as when I plug x in, I end up with a positive. And so this is negative 12 plus 21, which gives me 9. And so I have ED is length 9. Good thing they didn't ask me for CD because that would have been pretty much given to me. These last two, a little bit tougher, just because in how they give me the information. Now, there is a way around dealing with some of it, but I'm going to look at it a specific way that's going to help me always do these problems. I'm looking for PS, and that's the whole line segment. Shouldn't be too bad, though. What I need to do is somehow, well, I know the entire PS is x plus 23. That's given to me right here, from there to there. The problem is if I add up these two pieces, I've double counted this middle section right here. Well, I know what that middle section is. It's 4. So I can just add those together, x plus 11 plus x plus 20, and then take away one copy of that middle piece. I'll take away 4. And then we've got some combining like terms to do. I'm going to leave the left-hand side by itself. Looks like I get 2x plus 27, 11, 20, and negative 4. I'll go ahead and kind of do the same thing as before. I'll subtract x from both sides and subtract 27 from both sides. It's kind of hard to read, but that's okay. Those cancel. 23 minus 27 is negative 4. And so x is equal to negative 4. Which might be concerning, but when I plug it in, I think everything's going to work out. PS is just the x plus 23. And my pen's lagging again, making that kind of hard to read. Thank you. Make it look like I have worse handwriting than I already do. We get 19 for PS. Negative 4 plus 23 is 19. Okay, last one that we have to do here. Same kind of issue, right? I've got some overlapping pieces. I know that the entirety of VS is x plus 25. And so x plus 25 has to equal this piece and then this piece, and I got to take away that overlap. See right here, I've got some overlap between those two. So it's x plus 13 plus the 16, and then minus, I am going to put this in parentheses since there's more than one thing. That overlap is x plus 7. Now, I'm going to combine these like terms, but I'm also going to distribute. Actually, maybe I'll just distribute. Let's just do that. Let's not overdo it. X plus 13 plus 16 minus x, and then minus a positive 7, so minus 7. All right, like terms, I've got an x, I've got a negative x, and then a 13, 16, and negative 7. Kind of handle that part how you want to. The x and the negative x just cancel each other out. They go to 0. 13, 16, and negative 7 sounds like 22 to me. Now, if you're really clever, you'll notice that we're kind of done right now, but let's say we don't. I'll subtract 25. Here's my bet. I bet we get 22 as our final answer, but I want you to tell me why. 22 minus 25 is negative 3. And then in trying to find VS is equal to x plus 25. And so we'll go ahead and put that negative 3 in there. Negative 3 plus 25. And, oh, look at that. 22. Wow. Tricky. And so we get VS is 22. Again, don't get caught up on what x is. Make sure you finish your problem, find out what they're trying to have you find, and then you'll be good to go. That's about it. So make sure you do the problems on the back. There's a couple at the start that are kind of easy, but they're looking for some specifics on what we know based on some problems, and I want you to try to work through those. Otherwise, I hope you have a great day, and we will see you in class.